The other thing that will show up in your modules, if you click on an assignment, is a video link, but there isn't one because I haven't taught it yet. So I will teach the lesson, I'll try to record it, and then I will upload those videos every day. So they'll be posted in the lesson, so you could go back and rewatch it, or if you're absent, you can watch it that way too. So there will be a YouTube video for every lesson eventually, if I can remember to upload it and record it. Okay, so when we do solving systems, there's several ways. So we'll solve by graphing them. We'll solve by substitution. Have you talked about substitution in the past in math? Hopefully. And we'll solve by elimination. So the three main ways that we'll solve systems of equations. The one we're going to focus on today is graphing. So we're going to take a look at this first problem here, just as a quick warm-up. It says graph the lines on the same coordinate plane, name the point where they intersect. So that's what a solution is. A solution is the overlap of two lines. So it's the point where they meet that we're going to be giving as our answer. So if we're going to graph this equation, I or Mrs. Graham taught you a couple ways that you could graph. Do you remember any of those ways? Do you remember the first way we graphed? What form were we working from? Slope-intercept, right? I would say this one is easiest to graph from slope-intercept form. Is this in slope-intercept form? No. How do you get this into slope-intercept form? Okay, so I would add the 3x. You could subtract the 4, but then you'd have to move the y and it would be negative, and then you got to change signs. So I would say the quickest way to get there is add the 3x. So this would be y equals a positive 3x plus 4. Okay, I'm going to graph in different colors so you can see which line is which. So this one's blue for me. What do you do to graph this? What do you plot first? The 4. And where does that 4 get placed? Up, down, left, right. Where do you move? Up 4 from 0, 0, right? It's a y-intercept. So here's your y-axis. Here's your x-axis. We're going to go up 4. 1, 2, 3, 4. Okay. What's the slope of this line? It's 3. And how do you move for a slope of 3? Up 3 to the right 1, right? So we're going to go up 3 to the right 1, which is going to actually put us off of the graph. So if I want to go the other way with it, then I'm going to go down 3 to the left 1 if I keep that slope going. And I really like to keep it going as much as possible. You'll see, especially in today's lesson, why that's helpful. So our line right now looks about like that. Okay. This one, if we're going to graph it, I again would say slope-intercept is probably a fairly easy one, but you could also do the cover-up method on this one. Remember where you set x equal to 0 or you set y equal to 0? Shall we do it that way, or would you rather do slope-intercept? Cover-up? Okay, so if we do the cover-up method, essentially what you're doing with this one, and I'm going to do red on this one, is ignore that first part and set up two equations. So the first equation, or one equation, would be 2y equals negative 2. If instead we ignore the y portion of it, then our equation would be negative x equals negative 2. Okay, if we solve both of those, divide by negative 1, divide by negative 1, then x is 2. What does that stand for right now? What's that representing? The x-intercept, right? That's where we hit the x-axis, okay? So if x is 2, then on the x-axis, I'm going to put a point at 2. Okay, now solve the other part of it. Divide by 2, and y is negative 1, okay? That is a y-intercept. So now we're going to go where with that? Down 1. Okay, down 1 from where, though? From the point we plotted or from 0, 0? From 0, 0, right? It's a y-intercept. We want to be on the y-axis. So down 1 is right here. And then you draw that line in. Now here's the deal. You can see your slope for this. The slope of this line is going to be up 1 to the right 2. So if I go down 1 to the left 2, right, I could give myself more points there if I wanted. What we need to see is where do they meet? And that's right there. Can you name that point for me?
3 and negative 5. Mine I counted by twos. That is
On this part, you counted by twos?
Yeah.
Oh, your answer should still work the same though, because you want to count by twos then on your answer too, right? So this is a -2 and a -2. So the point would be -2, -2. Okay, that's what we're going to be doing today. You know how to graph each of those lines already, right? All you're doing differently now is you're finding where did they meet, and you're calling that your answer. All right, so that's going to be our process today. Here's why sometimes things like this come up. So here's an example of, they gave you your red line is the growth of a palm tree, and your blue line is the growth of a cactus. Notice they labeled inches and days. So if I look right here, let's say, okay, this red point, they're saying after 2.5 days, the cactus is what? 3 inches tall. Yeah. If I pick a point over, we'll say right here, after 9 days, that cactus is just over 8 inches tall, right? That's what that's saying. So then you look at the blue line. Well, the cactus, not cactus. Oh, sorry, I said that wrong. Red was a palm tree. Blue is a cactus. So the growth of the cactus started as a 3-inch cactus, okay? And it grew from there. So what we're looking for then is, where are the cactus and the palm tree the same height? Like, at what point does that happen? So if you look where they meet, we would say at 5 days, they're how tall? 5 inches. Yeah, after 5 days, they are 5 inches tall, right? This is where they meet up. So after 5 days, they're both 5 inches tall. That's kind of a real world application for when a graph like this is super helpful, as you can see different parts of like, when is what doing what? What's the relationship between the two? Okay. Okay, so like I said, a linear system is going to be 2 equations. So you have equation 1 and equation 2. The solution to that system is the point where they meet up. Basically, it's an ordered pair, right? An x and a y is going to be your solution. And where that x and y fits into both equations to make them true is where your solution would fall. So when x and y fits into both of them, then we know that's our solution. We call it a point of intersection. It's where they meet up, right? Where they intersect that we're finding. So if you look at this first example, it says find the point of intersection and then check to see if it works in both equations. Excuse me. So red meets blue at purple. What is that point? 2, 1, right? We always name the x first. So 2 to the right, 1 up. So that is the point, 2, 1. Okay. What they want you to do is check, is that actually a solution to this system? So what you're going to do is you're going to plug in 3 times the x value, which is 2, minus 3 times what? What? What's your y value? 1, right? Your solution was 2, 1. So 3 times 1 equals 3. So what we get is 6 minus 3 equals 3, or 3 equals 3, and that checks out. Okay, so we're saying 2, 1 is a solution to that first equation. Now check if it's a solution to the second one. So in your second one, you have 2 plus 2 times 1 equals 4. So 2 plus 2 equals 4, which is true. 2 plus 2 is 4. So it works in both. So we would say, yes, that is a solution. 2, 1 is a solution to that system. Okay. Any questions on that so far? Okay, then here's what we're going to be doing, okay? This is the steps to solving this. This first one isn't always necessary. Like in the first example we did, the warm-up, we didn't put it in slope-intercept for both of them, right? If you can do the cover-up method, I'm totally fine with that. If you want to do slope-intercept every time, then do slope-intercept every time. That's up to you. But we're going to put it into slope-intercept form. We're going to graph them both. We're going to see what point it looks like they meet at. which will most of the time be the actual point they meet at. And then you can always check it by plugging it back into the original equations. Now, if it's very obviously the point that you know, I don't make you check it. Why do you suppose it would be a good idea to check it? Yeah, you get to a quiz or a test and you say, I think this is my answer. Well, plug it into the equations and you'll know, yes, that is my answer. Okay, so check it, don't check it. I'm not super picky on that, but I think it's a great idea. I just won't mark you off if you don't check it. All right, so let's do this one together. And then I'll have you try one or two on your own and see how it goes. I gotta get used to my times again. This is fifth period. What time does fifth period end? 1:05. We're doing great. Okay. Here we go. So this first one, and I'm just gonna color code the way they already are. So the red one in red, the blue one in blue. Where do I move for that red equation? Y equals x plus 2. What's my first plot? Up 2, right? Your y-intercept is 2, so we're going to put a point right here. Okay, what's the slope of this line? It's 1. If there's nothing out in front, someone was saying it, we're going to go up 1 over 1, right? So from here, up 1 to the right 1, up 1 to the right 1. Again, you can go in both directions doing that same slope for as long as you want to. I like a lot of points, so I typically plot a lot of those points. So it'll look like that. Okay, then the blue line, where do you plot first? Down 2. So we're going to go down 2 right here. Your slope is 3. Remember, that's like a 3 over 1. We always treat it like a fraction. So we're going to go up 3 to the right 1, up 3 to the right 1. Notice we landed perfectly on another point that we already had. That's going to be your solution. So you draw that line in. Can you name that solution for me?
Two and 4.
2, 4, right? You go from 0, 0, 2 to the right, 1, 2, 3, 4 up. So 2, 4 is your answer. Okay. Take your time on those when you're graphing, because one silly little mistake on a graph and then your solution is totally wrong. So just take your time. If you struggle on graphing, please talk to me. I'm happy to sit down and help you with it. What I don't want is for you to struggle with graphing and then show up for a test, and that's where I find out that you're struggling with graphing. So make sure you ask, okay? I love to work one-on-one. It's my best part of my job. I love it. You are not hindering me. You are not bothering me. Ask for help, okay? Okay, letter B here. Again, you could do cover up or you could do slope intercept form. I will leave that up to you. Feel free to talk to your neighbor as you try it if you're not sure on something, or ask me for help. I'm going to give you a minute to try this one. If you finish this one, try the next one as well. And I'm just going to come around and see how it's going. I'm going to do cover up for the red and slope intercept for the blue, okay? So if we do the cover up method, basically what we're saying, just quick reminder for cover up, okay? The way we can do cover up is because we can treat this as a 0, right? That's going to give us an intercept. If my x is 0, then my y is what? Right? So really what you're doing is you're saying two equations. X equals -2 and y equals -2. The reason cover up is beautiful on this one is there's nothing to solve. It's done for you, right? So if these are intercepts, on the x-axis, we're going to go -2. On the y-axis, we're going to go -2. That's your line when you draw them in, okay? So you're going to take a line. Ooh. I'm not a Notability, so mine don't go straight. I did start recording again, thank you. So that's your first line, okay? If you prefer slope intercept, go ahead and put it into slope intercept. You would get the same line, okay? This one, I'm going to solve for y. I'm going to isolate the y. So I'm going to take away the 2x. So I get negative 3y equals negative 2x minus 9. And then I'm going to divide by negative 3 everywhere. Make sure whatever you do on that side, you do it to the whole other side. So this is y equals, what's negative 2 over negative 3? Positive. Yeah. So that's 2/3 times x. And then negative 9 over negative 3 is a positive 3. So this is the line that we're going to graph. Okay, that's in slope-intercept form. Where do you move first? Plus 3. So 1, 2, 3 is 3 up. And then with a slope of 2/3, and here's where you have to be careful, okay? Slope is rise over run. Rise is up and down. Run is to the right, okay? So I'm going to go up 2, 1, 2, 3 to the right. Same thing if I went the other way. Down 2, 1, 2, 3 to the left would put me right there. And if you notice, that's exactly where my other line went through. So what is the solution to this system? In other words, what is the name of that point? Negative 3, right? 1, 2, 3. Ooh, up 1. So negative 3, 1 would be your solution. Okay. Questions on that? Okay, let's do the next one together. These are both in slope-intercept form, which is beautiful. You don't have to do anything to them. You're just going to graph them. So this first one, plus 4, where do you move? Up 4. 1, 2, 3, 4. Okay, that's my y-intercept, right? That's my y-axis. And then your slope is 2. Remember, that's 2 over 1. So you're going to go up 2, 1 to the right, and plot that point. Again, if you want to keep it going in the other direction, so you have a nice straight line, down 2 to the left, down 2 to the left. You just want to keep that slope going. Okay, so here's your line. Okay. Then your second one, y equals x plus 2. Your y-intercept here is 2. So I'm going to go up 2, and I'm going to plot that point. What's the slope of that line? It's 1. So up 1 over 1, right? Up 1 over 1. And again, if you keep going in the other direction, you'll see exactly where they meet is at that point right there. My line doesn't look like it, but my points were in the right place. What is that point of intersection? Negative 2, 0. Make sure it's always the x value followed by the y value, okay? Don't swap those. That's not 0, negative 2. That's negative 2 and 0, okay? Questions on that? Okay. Then the last thing looks very similar, but you get slightly different types of answers here. So I'm going to graph both of these for you. One of them is going to be an infinitely many solutions situation. The other one is going to be a no solution situation. Now here's my question. Based on what we've been doing, when we graph, so far our solution has been a point where they met up. Can you tell me what the graph might look like if it is no solution? Khalees. Parallel, right? If you have parallel lines, they won't meet anywhere. That will be no solution, okay? So you should be able to tell kind of just from the equations if there'll be no solution, okay? Take a look at this first one. We're going 2x plus 2. So we're going to go up 2. And then our slope is 2. So up 2 to the right 1, up 2 to the right 1. So that gives us this line. Okay, our blue line, we start at negative 1, so down 1. And then it is up 2 over 1, up 2 over 1, and we graph that line. Okay, and what you notice is they have the same slope, but different y-intercepts, so they are parallel, right? Two lines that are parallel have the same slope. So these are parallel lines. How many solutions do they have? No solution, right? If they don't meet, there is no solution. Questions on that? Okay, then go to this next one. And you can see right down here, there's technically 2 lines graphed there, right? Red and blue meet to make purple. So it's as if they graphed 2 lines, but they're the exact same line, which means every single point is the same point of intersection, right? So that's infinitely many solutions. You may write IMS if you want for infinitely many solutions. I'm fine with that. But let's just take a look at how this one shows up. Again, I would do cover-up method on this, but you don't have to. You can totally put it into slope-intercept form if you want. But for cover-up, you're just writing 2 equations. You're saying 2y equals 2, and then you're saying negative x equals 2. So if I solve that, divide by 2, I get y equals 1. What does that represent? Y equals 1. What did we find? That's up 1. It's your y-intercept, right? This is an intercept. It's where it hits an axis. So I'm going to go up 1 right here. Okay? The other equation, we're going to divide by negative 1, and we get x equals negative 2. What does that represent?
Down 2.
Not down 2.
Oh, down 2
Over. Down to over.
Up.
X equals negative 2 is an intercept, right? These are intercepts.
Oh, it's just negative 2.
It's just negative 2. It's just to the left 2, right? Your x-intercept is at negative 2. It's where you hit that x-axis. So if that's the setup, then my line is just, oh, that's terrible. Hold on. We're going to keep that slope going a little bit. Okay, so here's my line. Okay, again, if you hate the cover-up method, don't do it. Turn it into slope-intercept form. That's totally fine, okay? I'm just giving you options. The blue line is in slope-intercept, so we're going to go up 1. Look at that. There's our answer. And then a slope of 1/2. So up 1 over 2, up 1 over 2. If you go the other way, down 1 over 2, down 1 over 2. We get the exact same line that we just drew in. If they are perfectly on top of each other, then there are an infinite number of solutions, okay? So this is infinitely many solutions. If you want to write IMS, that's fine. If you want to write infinitely many, that's fine, okay? Here's your little cheat for how to remember it. Any questions on that? Okay, you may use cover-up, you may use slope-intercept. Choose the one that you like better and run with that, okay?